Hi, this is Steve Smith.
And this is Julie Lerman. Welcome to our course, Domain Driven Design Fundamentals.
We're looking forward to sharing our experience with DDD and how it's helped us and our clients. You're welcome to reach out to us online.
You can find me online at thedatafarm.com or on Twitter at Julie Lerman.
And I'm online at ardallas.com or on Twitter as @ardallas.
Eric Evans coined the term domain driven design in his groundbreaking book with the same title, published in 2004. Since then, other titles have followed, including great books expanding on the subject by Jimmy Nilsson and Von Vernon, and so many who are now also great experts at DDD. And there are also now a number of fantastic DDD conferences and even a well-established virtual meetup.
There's definitely continued and renewed interest in domain-driven design as both the demand for and complexity of software continues to grow. Domain-driven design is commonly referred to as DDD and even has its own Twitter hashtag, DDDesign. Although DDD has been around for so long, it continues to be a great approach to building software that we both enjoy employing and sharing with others. And as more minds have gotten involved in DDD, it continues to evolve.
Domain-driven design is a huge topic. Our focus will be on the developer perspective and the technical and coding aspects of DDD more so than architectural concerns. We'll start by talking about why we think you should even be watching this course. Next, we'll jump right into an existing solution so you can get a concept of what the code and the architecture of an application written using DDD practices looks like. Then we'll start digging into the big DDD concepts like modeling problems of the domain, what the various technical components of DDD are, and how you can use DDD to manage complex projects. Throughout the course, we'll use the existing solution so you can see how some of this process works.
With this in hand, we'll walk through extending the sample based on a new request from the client. Since this is a fundamentals course, we certainly don't expect to turn you into an expert by the end of it. However, you should be well on your way to understanding the value behind domain-driven design and how some of the practices can be employed to improve your success with complex software projects. Right now, if you're new to DDD, you don't even know what you don't know yet. However, once you're done with this course, you'll know more about DDD, but of course you'll also realize how much more there is to learn. That's one of the great things about our industry. The more you know, the more you realize how much more there is you don't know.
In this module, we'll focus on the value of domain-driven design. You'll learn what the term represents and what problems DDD can help you with in your software building process.
Not only will we share the benefits of DDD, but we will be sure to highlight some of the potential drawbacks. Finally, you'll get a look at a small application that we'll be using throughout the course as you learn DDD.
Domain-driven design focuses on the problems of the business domain that you're attempting to solve. It's a critical shift from decades of focusing on how to store your data and then letting that drive how the software is designed. But that workflow added a lot of unnecessary complexity to the task of building software. So why should you watch this course? Why should you care about learning domain-driven design? Steve and I have both been designing and developing software for a very long time. Without giving away our ages, we've got over 40 years of experience between the two of us. And we've both been very inspired by domain-driven design. In many ways, it aligns very naturally with ideas that we've each come to from our own experience. It also takes these ideas and lays them out in a way that's not only illuminating, but it's repeatable. When Eric Evans wrote his book, his goal was to understand what was behind the successes he had achieved with large-scale, complex software projects, and what were the patterns. That's what he laid out in the book.
This is why we care about DDD, and we hope that you can gain from our experience, which is why we put together this course. DDD provides principles and patterns to help us tackle difficult software problems and even business problems. These are patterns that are being used successfully to solve very complex problems. The more we've learned about DDD, the more we've found these ideas align with the approaches we've learned from our many combined years of experience. DDD provides us with a clean representation of the problem in code that we can readily understand and verify through tests.
We developers live to code. When starting on a new project, we're eager to jump in and start coding so that we can build some software. But you can't build software unless you truly understand the client's needs. DDD places as much emphasis on not only comprehending what your client wants, but working with them as full partners through a project. The ultimate goal isn't to write code, not even to build software, but to solve problems.
You need to realize that nobody really wants your program. They want what it can give them. There's a famous saying in sales: buy a quarter-inch drill. They want to buy quarter-inch holes. Your client's not interested in building software, but in being successful at their mission. Software provides a more efficient means to this end.
Domain-driven design is for solving complex problems. Evans put a lot of thought into the subtitle of his DDD book and came up with Tackling Complexity in the Heart of Software. But DDD itself is a complex topic. To start with, we think it's helpful to look at it from a very high level. We call it the 10,000-foot view here in the U.S., but that's probably 3,048 meters to the rest of you.
One of the critical pieces of DDD is to encourage better interaction with domain experts. These are the people who live and breathe the business or process or whatever you are targeting with the software you are planning to write. You may be thinking, but we already talked to them. Perhaps, but probably you're using your terms, not theirs, and maybe talking in the language of tables in a database rather than domain concepts. Or you may presume that after some standard requirements gathering, you can infer enough about the problem at hand to design the solution on your own. After our own history in the business of developing software, we know that that rarely ends well. DDD guides us to engage with the domain experts at much greater length and through much more of the process than many software teams are used to doing.
When talking with Eric Evans about this, he told us that you really need to cultivate your ability to communicate with business people in order to free up their creative modeling. Another core theme in DDD is to focus on a single subdomain at a time. Say you're asked to build software for a spaceship manufacturer. They describe their business tasks such as purchasing materials, engineering, managing employees, advertising their spaceships, and share with you their dreams about mass-producing spaceships when the market's ready. Each one of these tasks are, in themselves, a complex subdomain filled with their own specific tasks, terminology, and challenges, and those subdomains may have only minimal interaction between them. Many applications just try to do too many things at once. Then adding additional behavior gets more and more difficult and expensive. With DDD, you'll divide and conquer. By separating the problem into separate subdomains, each problem can be tackled independently, making the problem much easier to solve. This lets us focus on the problem of employee management separately from the problem of sourcing materials for producing the spaceships. The term modeling is important in DDD and refers to how you decipher and design each subdomain. You'll learn much more about this as you progress through the course.
The final theme in our high-level perspective of DDD is writing the code to implement each subdomain. The principle of separation of concerns not only plays a critical role in identifying the subdomains, but within each subdomain we use it as well. Many applications spread the domain logic between the persistence layer and the user interface, making it much more difficult to test and to keep all of the business logic consistent. DDD applies separation of concerns to help steer you clear of this problem by focusing on the domain and not on details like how to persist data into a database or how to connect to a service in a cloud. Those become implementation details that you can worry about separately. While implementing these subdomains, the focus is on the subdomain, the problems of the subdomain you are trying to solve with your software. You don't get bogged down worrying about infrastructure concerns.
Domain-driven design is a big commitment. While Steve and I have both chosen to leverage pieces of DDD as we learn more about the wider scope, one thing we're both confident about is that it's providing a lot of benefits to our work. Because DDD guides us to focus on small, individual, nearly autonomous pieces of our domain, our process and the resulting software is more flexible. We can easily move or modify the small parts with little or no side effects. It even lets us be more flexible with our project resources as we're building the software.
The resulting software also tends to be more closely mapped to the customer's understanding of the problem. DDD gives you a clear and manageable path through a very complex problem. When you look at the code, you can see that it's generally well organized and easily tested, and the business logic all lives in one place. Even if you don't use full DDD for a project, there are many patterns and practices that you can use by themselves to benefit your application, so keep watching even if you don't think you'll need all of it.
We often describe DDD as a way to take big, messy problems and transform them into small, contained, solvable problems. But DDD is not a path for every project. Its real benefit is for complex domains. Even Eric Evans explicitly states that DDD isn't suitable for problems when there's substantial technical complexity, but little business domain complexity. Using DDD is most beneficial when the complexity of the domain makes it challenging for the domain experts to communicate their needs to the software developers. By investing your time and effort into modeling the domain and coming up with a set of terminology that's understood for each subdomain, the process of understanding and solving the problem becomes much simpler and smoother.
But all of this comes at a cost. You'll spend a lot of time talking about the domain and the problems that need to be solved, and you'll spend plenty of time sorting out what is truly domain logic and what is just infrastructure. The easy example there is data persistence. Or, for the sake of our spaceship manufacturer, maybe it's how to communicate with an external service that helps to verify that potential buyers are properly vetted for space travel.
You'll have a big learning curve as you learn new principles, patterns, and processes. There's no question about that. DDD is a big topic, and gaining expertise from end to end is a big commitment. This course doesn't aim to make you an end-to-end expert in DDD, but to give you a big step forward that will allow you to not only comprehend the concepts, but you'll gain a lot of new tools that you can use right away, whether or not you choose to dig further. And it's worth restating that DDD is not always the correct path for your applications. And it's helpful to keep in mind some of the scenarios where DDD is just going to be overkill. For example, if you have an application or a subdomain that's just a data-driven app and doesn't need much more than a lot of CRUD logic, there's really no need to use DDD. It would be a waste of time and effort.
And be clear about the difference between complexity in your business domain and technical complexity. DDD is designed to help with complex domains. If your domain is simple, even if you have a lot of technical challenges to overcome, DDD still may not be the right path. For example, if you are writing a tic-tac-toe game for a touchscreen with a new complex API, the complexity lies in the touch interactions of the two players on the screen. The domain itself is well known and just comes down to X's and O's. Getting others to follow the DDD approach can also be a drawback. There may be some politics involved in this decision. It really depends on your team and your organization. We hope that another takeaway from this course will be to help you understand the concrete benefits of DDD, which you can show to your coworkers to help convince them.
In his DDD book, Evans included a really useful diagram of how many of the concepts and patterns of DDD are interrelated. Let's take a look at that mind map.
Evans refers to this as a navigation map, and it lays out all of the pieces of domain-driven design and how they relate to one another. We want you to see it so that you have a concept of the big picture, even though in this course we'll spend most of our time on a subset. We will be defining many of these terms later on in the course, so don't panic. We've mentioned modeling the domain and subdomains a few times. Modeling is an intense examination of the problem space. Key to this is working together with the subject matter experts to identify the core domain and other subdomains that you'll be tackling. Another important aspect of modeling is identifying what's called bounded contexts. And within each of these bounded contexts, you focus on modeling a particular subdomain. As a result of modeling a bounded context, you'll identify entities, value objects, aggregates, domain events, repositories, and more, and how they interact with each other.
In the image, there's more than just these subdomains, however. For example, there's a concept of an anti-corruption layer, which allows subdomains to communicate with one another from behind their boundaries. The model also has notes for each element, such as free teams to go separate ways. This is something that can be accomplished once you've identified the boundaries of each subdomain. Or avoid over-investing in generic subdomains. That could be something like a credit card verification service that you could choose to use rather than building yourself. As you begin focusing on specific subdomains, another very important DDD concept surfaces, driven by the need for clear, concise communication. It's called the ubiquitous language. A simple definition of a ubiquitous language is to come up with terms that will be commonly used when discussing a particular subdomain. And they will most likely be terms that come from the problem space, not the software world. But they have to be agreed upon so that as discussions move forward, there is no confusion or misunderstanding created by the terminology used by various members of the team.
We invite you to pause this video to look over this map and read the notes associated with the various elements and contemplate what they might mean. We'll revisit this throughout the course, and we hope that the map will make more and more sense as you work through the course.
Now we want to switch over and show you a relatively small DDD-based solution that we'll be working on for the rest of the course. This app represents an appointment scheduling system for a veterinary clinic. It's small, in air quotes, but since DDD requires a certain amount of complexity to warrant its use, it's bigger than most demos you'll see in other courses or presentations. For this course, we decided that we would use a veterinary clinic management system because it has a decent amount of complexity, and that means that we can apply some of the DDD principles, but It also gives us an excuse to show off pictures of our pets.
And our friends' pets, too. We got a whole bunch of pet pictures from other Pluralsight authors in here, and they're all so cute.
We've got Ben Franklin here from Michael Jenkins. We've got Patrick Nieborg's dog here, Sugar. Aren't these guys cute? And of course, Julie's got Samson.
Oh, my handsome boy.
And I've got Darwin, the silly poodle. He was just a puppy when we recorded the first version of this course. And he's got a new friend, Rosie. Rosie's just a puppy. I guess every time I get a puppy, we have to update this course.
So the idea behind this application is that if you're working at the front desk of a vet clinic and someone walks in, maybe they want to schedule an appointment, or the phone rings with someone who wants to schedule an appointment for their pet, the first thing you're going to do is look that client up, the person, in the system.
So the user starts by looking up the client, and from there they can choose which of the client's animals or patients they're going to schedule. So here's Julie with Samson. Here's Kim with Roxy. Next, the user's just going to click on an open slot in the schedule, which opens up the Create Appointment window.
Oh, Roxy, you're such a cutie. We can set up Roxy for a wellness exam with Dr. Smith.
Now, notice before we save this appointment, it isn't yet confirmed. We'll get to that in a minute. So we save, and the appointment shows up. Now, the complexity in the system comes into play when we have to do some checks for certain things. We want to make sure, for instance, that Roxy isn't already scheduled in one of the other rooms at this exact time. We also want to send an email notification to Kim to let her know that Roxy has this appointment scheduled. We'll add a link in the email the client can click to confirm, and in a real system, perhaps it would add it to their calendar of choice. The idea is to cut down on no-show appointments for the clinic.
Of course, there are other features of this application. We're focused on the schedule right now, but we do need to be able to manage client data and manage their pet data, the clinic's patients, and things like that. Admins need to be able to manage doctors and rooms and appointment types, since these all might change over time or from one clinic to another that uses the same software. But those are mostly CRUD tasks, which means we're just talking about adding and removing records and maybe making some edits without a whole lot of complexity. We'll talk about those tasks in a different compartment of the application than the schedule, which of course has a lot more complexity.
So why don't we take a look at the structure of our app. This is a distributed application built with ASP.NET Core on .NET 5. It's running Blazor WebAssembly in the front end, which is talking to APIs running on ASP.NET Core. There are 3 different web apps that the system uses. 2 are used internally by client staff, and then there's the public-facing website for the clinic, which is needed for the confirmation links that users will click. The 2 clinic apps, Front Desk and Clinic Management, each have their own database, and all 3 apps communicate with one another using messages transported by RabbitMQ. Like I said, it's maybe a little more complicated than most demos. We want the sample app to be something you spend some time with and extend as part of your experience with this course, so please be sure to check it out and run it locally. It should just work if you have Docker installed.
Now let's take a quick look at how the code is organized. The full solution is hosted on Steve's GitHub account. Here's the URL, but we'll definitely also have that URL in the resources slides at the end of this module. Pluralsight DDD Fundamentals is the name of the root of our GitHub repository. In here, you can see the 3 web apps, Clinic Management, Front Desk, and the public-facing website, Vet Clinic Public.
There's also a folder for shared kernel, which we'll talk about a little bit later. The first app we're going to focus on, though, is the Front Desk app.
Our main focus for this course is going to be the Front Desk application and its scheduling functionality. Looking at the solution, you can see it's broken up into 7 projects, which seems like a lot, but 3 of them are just there to support Blazor. The server-side code, where our domain model resides, is just 3 projects.
The most important project is frontdesk.core. That's where the domain model is defined. All of the app's infrastructure needs, like how it talks to its database or RabbitMQ, are kept in the frontdesk.infrastructure project. And the front end, in this case ASP.NET Core and its API endpoints, is in the frontdesk.api project. This is the front end from the server's perspective. The system is using a clean architecture design, which you may also hear referred to as onion architecture or ports and adapters. I cover this in my N-tier applications in C# course, and I have a popular GitHub solution template you can use to set up a new project using this approach.
With clean architecture, the project dependencies all point towards the domain model in the core project. So both the API and infrastructure projects have a dependency on core. Core should never depend on infrastructure concerns, but it can leverage NuGet packages that don't couple it to infrastructure concerns.
In this case, it's using a couple of utility packages, as well as the shared kernel package that's shared by other apps. We'll talk more about shared kernel later. The clinic management app uses the same kind of structure and also has a Blazor front end because why not? It's pretty much just CRUD, so we don't focus too much on its domain model, but it is a distinct app with its own database, and we do need to build into our design a way to propagate changes from it to the front desk app.
Finally, there's the public web app. It's just one project, and it's pretty simple. This is responsible for sending emails, which this demonstration fakes using a tool called Papercut, and it hosts the link that clients click to confirm appointments. The public web app also needs to communicate with the front desk, but it doesn't have a database of its own, nor does it access any of the other app's databases.
That's it in a nutshell. We'll demonstrate the confirmation emails and more complex use cases later in the course, but for now, that should give you an idea of how the ideas we're sharing are put into practice.
So as we've talked about, creating applications is not about writing code, even though often that's a really, really fun part for us developers. But it's about solving problems. And the more complex the problems are, the more difficult the whole project becomes. So domain-driven design gives us some great patterns and practices for attacking these more complex problems. And they get us to really focus on interacting with the domain experts, breaking apart our domain and working on things in smaller units and in a very organized fashion. And in the end, it gives us a much more efficient and effective path to success in creating our solutions.
Yeah, we talked about some of the benefits that domain-driven design provides, as well as some of the drawbacks. Specifically, your team just needs to know domain-driven design, and your domain experts need to be available to work with you on these systems. Domain-driven design is a big topic. We looked at some of the different concepts that are involved in DDD, and we're going to look at a lot more of them in depth through this course. But remember that this is just an introduction to domain-driven design, so some of these aspects that are a little more advanced, we're not going to be able to cover with a great deal of depth.
In the next module, we'll start exploring the process of discovering and modeling domains. Here are some links to resources that we mentioned in this module and others that we find relevant.
This is Steve Smith.
And this is Julie Lerman, and thanks for watching Domain-Driven Design Fundamentals.